Okay, so here's the truss, and you have the forces at 3 kips. Then we got a number of joints as A, B, C, D, E, F, G, H, and I. So those are the joint numbers of the letters, and then the question here is to find member forces in members, and we're looking at member BD, looking at member DE, and we're looking at member FH. There is another member here. Okay, so what we're looking here is we're looking at force in this member, we're looking at force in this member, and we're looking at force in this member. Now, when you get a problem like this, then if you notice that you got two members together, then one is here. So if I pass a section which goes like this, then there will be too many unknown forces on the free body diagram. So we need to work through this problem in 2 steps. First step is to find this force and this force, or we are look at a section which goes like this. That means we'll have the top part where we're going to remove this member, and this member. That should allow us to find this force and this force. Then for the second part, we're going to have to look for a section which probably will go like this. So it's a little bit tricky, but that's how the section going to look for the section will look for finding the force FH. So let's look at the first one. If I draw the free body for the top, this is joint A, joint B, joint C, that's joint D, that's joint E. And then we got the forces. We have force here, 3 kips, force here, 3 kips, another force here, 3 kips. And then you have the bottom part here. Now, you're saying that this member is not there. So if that member is not there, we have to remove it. In place of that, we need to place a force. So at joint B, I place a force. I call this as FBD. And again, the assumption is that the member was in tension. Then it cuts through this member. That means this member is no longer there either. So at this joint, there will be a force. We call this as, let's say, FED. Then this member is also not there anymore. So since there is no member, there will be a force in that direction, and that will be FEG. So when we isolated the top part of the truss, then it said that since this member is taken out, then at joint B, you place the force FBD. Then the member DE is taken out, you place a force here as FED, and you did the same thing here. And so that's what you get as the free body, where this is going to be 15 feet, this is going to be 10 feet, and this is going to be another 10 feet. another thing which I should point out at this point is that when you look at a member, let's say if you look at member DE. Now this one at this end could have a force, let's say FDE. Then on this end, it could have a force FED. I mean, there are two different ends, so there are a possibility of having two different forces. But this member has to be in equilibrium too. So your FDE is the same thing as FED. So that's why I don't make any distinction between which one I'm going to write first. I mean, I could write this as FED, or I could write this as FDE. It still count as the force in member DE. And the reason behind that is simple, that these two end forces have to have an equal magnitude. Okay, so again, now if I sum the moments above point A, that should go to 0. And the reason we choose this point is this force goes through it, this force goes through it, so these two will give 0 moment. The D will be 0, so you get FED times 20, that's clockwise, so you place a negative. Then we have 3 times 20, that's counterclockwise, so positive. Another 3 times 10, and that goes to 0. So you get FED as 90 over 20, or 4.5 kip, came out positive, remains in tension. So that gave us our first force. I mean, we needed this, and we already have it. Then you need this one, and if I choose point E, that means if you sum the moments about E, that should also go to 0. Now, this